So in this question we have a beam that is held in equilibrium by two vertical ropes, one rope being attached to A and the other being attached to point C. The beam is modelled as a uniform rod and the ropes as light strings, and the beam has mass 12 kilos and length 5 meters. I think it's always helpful to redraw these pictures. So that's exactly what I'm going to do. So we have this beam here, and we have two strings, and at A and C, we have B here. This length is 1 meter. The whole length is 5, so this length is going to be 4 meters. And it's a uniform rod, which means that the mass is going to be centered. The center of the mass is going to be exactly in the middle. So say we have, obviously this diagram's not to scale, we have 12 times G newtons, and that's going to be, that distance there will be 2.5 meters, which is half of 5. And this distance here is going to be 4 minus 2.5, 1.5 meters. We're asked to find the tension in the rope at C. And so we have tension here, call that T subscript A, and we have tension here, T subscript C. And these tensions are not going to be equal because they're not an equal distance from the center of mass of the beam. So, given that these two aren't equal, how are we going to find the tension in C? Well, the best thing to do is to take moments about A, and then we can ignore the tension at A and just focus on the tension at C. So if we look at the moments about A, okay, in the clockwise direction, we have this 12g times 2.5 meters. And in the anti-clockwise direction, we have the tension in C times 4 meters. And we know that it's in equilibrium, in other words, it's not moving. So that means that these two must be equal to each other. So we can set them equal to each other. So we have 2.5 times 12 is equal to 4 times the tension at C. And so this gives us 30 G over 4 equals tension at C, which is equal to 7.5 G. And there we go, that gives us the tension at C. So how do we find A? Well, now that we have the tension at C, we know, let me just make a tiny bit more space here. We know that the tension here plus the tension here is going to equal this force here, because it's not moving. Now we have the tension at C. We could say that TA plus TC is going to be equal to 12G. So let's just do that. It's T at A is going to be equal to 12G minus the tension at C, which we've just worked out as 7.5G, which is equal to 4.5G. And there we go, that's part A done.